This week we're going to be working on pages out of Module 3, 155 to page 166. This section is really where we put everything together, and we're going to introduce inequalities to graphing, tables, charts, and word problems. And if given any one, we want to be able to convert it into the other three. This week we'll also have some negative slopes or negative rate of change highlighted in some of the problems. And so we've talked about it. This week we're going to be working with it more closely. And so, again, this week's going to focus on introducing inequalities to these types of problems, to these two-step equations. The warm-up is going to be just refamiliarizing ourselves with inequalities. And so determine the parts of the solution that make each inequality true. Out of the numbers, the solution set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to 15, which of these numbers is true? Which of these really is a solution set for x being greater than 6, or x plus 2 greater than 6, 2x plus 2 greater than 6, 6 less than 2, open parenthesis, x plus 2 minus 4. So take a look at those, and while you're working on those, again, we're going to be solving word problems by building and interpreting inequalities of the form px plus q less than r, px plus q greater than r. Don't panic when you see that, please, because, again, we have some different letters here because we have some slightly different things, p's and q's. They're using different letters, different variables to represent different aspects, different particular things. But this really can still be, we've done slope-intercept. And if you remember slope-intercept, is y equals mx plus b, is slope-intercept form. Well, they're talking about px plus q less than or greater than r. How do those two look alike? Again, different letters and a different, an equation versus an inequality. But in this case, P represents M. That's the slope. Q is where the line crosses the y-axis. That's the B value. And R is Y. So this could also be some value greater than mx plus b, or some output is less than some input. So again, with different letters, there's going to be some little nuance to recognize when we're working with these, but it's fundamentally the same. And so again, please don't panic. It's going to be okay. We have to make sense of the problems. They're using these variables, these letters, to represent the problem situation, but it's very, very similar, very familiar to what we've been working with already. There's not that much new being introduced here. We've already worked with inequalities. And remember that one funky rule with inequalities, that you have to flip the inequality sign when multiplying or dividing both sides of the inequality by a negative. So, for example, if you had negative 2, I'll say x, greater than 10, and you have to get x alone, when you divide both sides by negative 2, because negative also means opposite, you get the opposite of this inequality sign. This greater sign turns into a less than sign. X is less than, positive divided by negative is negative, 10 divided by 2 is 5. So this inequality flips. This was just an example. And we've talked about, oops, I don't have that on my video, sorry. Negative 2x greater than 10, we had to divide both sides by negative 2, and that caused this inequality sign to change direction, to flip. So this greater than sign became a less than sign because we needed to get x all alone. So this was just a little example reminder. And warm-up problems 1 through 4 are just reminders. We've already worked with inequalities. We've already solved a bunch of them. They're very much like solving our linear equations. In this case, we're solving linear inequalities. So let's take a look at these. Number 1, for x greater than 6, well, that's all numbers greater than 6, and out of our solution set, there's no fractions, decimals, percents, it's just whole numbers. So it's just, 6 is not a solution because x has to be greater. So it's literally 7, 8, 9, 10, 11, 12, 13, 14, 15. I'll put commas between to separate. That's our solution set for 1. On number 2, they're asking us to simplify or to solve for x first. And so on number 2, we have x plus 2 greater than 6. Well, we have to get that x all alone. And x has a 2 being added. So let's subtract 2 from both sides of this inequality. The subtraction property of inequality, since we're working with an inequality, 2 minus 2 is 0. So I just have x on this side of the inequality. 6, take away 2 is a positive 4. So all numbers greater than 4. So 1's not a solution, 2's not a solution, 3's not a solution, 4's not a solution because it has to be bigger than 4. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Probably the lengthiest part of these problems is just writing out the solution set. Problem number 3, again, we're going down memory lane. 2x plus 2 greater than 6. 2 times x plus 2 is greater than 6. And we need to get somewhere down here, x all by itself. All by myself. Okay, beautiful singing there. We need to get x alone. Oh, there's my lovely hound dog barking at somebody on the street. So 2x plus 6, or 2x plus 2 is greater than 6. Let's get rid of this 2 first. Let's subtract a 2 from both sides of this inequality. So that created a 0 pair. So all I'm left with on this side of the inequality now is 2 times x. On this side, 6 minus 2 is 4. Well, I need to get x all alone, and x is being multiplied by a positive 2. So divide both sides by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And again, there was no need to flip this inequality sign because I divided both sides by a positive number, so nothing changed. But had I divided by a negative, that sign would have changed direction. Well, I need all the solution sets for x greater than 2. Well, that's 3 through 15. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's the solution set. And finally, number 4, I wish I would have left myself a little more room, but I'll fit it in over here on this side. I put my example dealing with the negative where I should have left room for number 4. 6 greater, whoop, that's less than. I need to pay attention to my signs because messing up your signs will mess up your problem. 6 less than 2, x plus 2, take away 4. Well, we need to simplify this one side, and so I'm going to distribute this 2 into the parenthesis. I'm going to go 2 times x and 2 times a positive 2. So I have 6 less than 2 times x is 2x. 2 times positive 2 is plus 4 minus 4. And then we have combined like terms. I'm just going to put those two together. And I have 6 less than 2 times x. Well, I need to get that x all alone. X is being multiplied by a 2, so I'm going to divide both sides by 2. So the division property of inequality. 2 divided by 2 is 1, so that is 1x. That we just write an x. We don't put the 1 in front. You can. You'll get tired of writing it because it's extra work that you'd have to do. 6 divided by 2 is 3. So 3 is less than x. Or x is greater than 3. The alligator mouth wants the x, it always wants the larger quantity. So my solution set out of my solution set, the answers that fit this are bigger than 3. So my solutions for this are 4 through 15. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 are my solutions. So again, brief trip down memory lane on solving two-step equations, and this had pretty easy ones because it didn't introduce any negatives. So again, we didn't have to flip a sign, but these were all very friendly inequalities. And again, we're going to be graphing them. We're going to have two-step, like some of the two-step inequalities. These all just had one variable. All of them just had an x. We'll have inequalities with two variables, x and y's, and we can solve for x or solve for y. And so we'll be graphing them on a two-dimensional graph with x and y. All right, let's take a look at page 156, lemonade at the pool. A concession stand at a local swimming pool sells small and large glasses of freshly squeezed lemonade. This weekend, they made more than $250 selling glasses of lemonade. A large glass of lemonade sells for $4, and the total sales generated from selling small glasses of lemonade was $65. So we've made more than $250, not $250. We actually made more than it, so that we have to pay attention to our signs. And we know, so what we have here, write an inequality to represent the relationship between the amount they made and the number of large glasses they sold. So what we know is we're going to have money made, our total, and we already know that at least. If we let t equal total, in this case, our t is greater than 250. So we know what they made was greater than 250. I'm going to let L be large glasses of lemonade. And I'll let S be small glasses. And they told us they made $65 there, so this actually equals $65. So if I was doing this, I could have my total, that's supposed to be a T, total, and what they made was, like the total, well, they made 250, so I'm just going to go straight to the 250, and they made more than that. So the quantity over here is large glasses of lemonade. Oh, and how much does a large glass cost? $4 each. $4 per large glass of lemonade, plus the $65 they made for small lemonades. So, and they made, again, this is more than $250. And I could have also written this 4 plus 65 that's greater than $250. So does it really matter with this if I change the side? For example, on this one, I had 3 is less than x, or x is greater than 3. 250 is less than 4 times the number of large glasses of lemonade sold, plus $65, or that this is greater than 250. Solve the inequality in terms of the problem situation. Let's pick one. I'm just going to solve one of them. I'm going to solve this one. And again, it's going to be the same answer. It's going to put them on different sides of the inequality sign. So 250 is less than 4L plus 65. Actually, I'm just going to solve both of them really quick. On a normal basis, you would just solve one or the other, but you wouldn't have to solve both. And so I need to get L all alone. So I'm going to subtract 65 from both sides. $250 minus 65. Well, 250 minus 50 of this would be 200. And if I just had 50, that would leave me 15. 200 minus 15 is 185. So 185 is less than 4 times L. And it's going to look the same over here. I need to get L alone, so I'd subtract 65 from both sides. And again, subtracting, adding or subtracting the negative there doesn't flip the sign. It's only if you're multiplying or dividing both sides by a negative. Then the inequality sign flips. So over here I get 4 times L is greater than 185. Well, I need to get this L alone, so I'm going to divide both sides by 4. 4 divided by 4 is 1, so I have 1 L. So the cups of lemonade sold has to be greater than. 4 goes into 18. Well, 4 goes into 16 4 times. And that would have left me 25. 4 goes into 25 6 times with 1. 4 goes into that. So it's going to be 46.25. And over here, it's going to be L greater than 46.25. So they're not selling lemonade by the partial cup. That wouldn't make sense. Somebody's not coming up and going, well, I'll charge you $1 for a fourth of a large cup. They're only selling large and small glasses. So if it's greater than 46.25, it's going to be 47 or more. Because it just had to be greater than 46.25, and 47 is greater than 46.25, so it can be equal to that or more. 47 or more large glasses sold. Graph this on a number line. Well, I'm dealing in the 40s, so I've got 47. So somewhere down here, I'm going to start spacing out my number line. I should have put less tick marks on because then I'd have less numbers to put in. I've just created extra work for myself. And 47, I want somewhere in the middle. So 47, 46, 45, 44, 43, 42, 41, 40, and 48, 49, and 50. I'm going to go with right there. Well, this had to be more than 46.25, but again, we're not selling partial cups of lemonade. We're selling whole cups of lemonade. And the biggest whole number larger than 46.25 is 47. And they could have sold 47, so it can be a solid line there, or a solid circle. And they sold more than that, so it goes that direction towards the larger. And I'm going to put my L there on top of that line to show that L is greater than or equal to 47. L is greater than or equal to 47. Or 47 is less than or equal to L. So again, this is still review of things we've already done. We're reviewing. Let's take a look at 3.1. I'm going to get you started on this problem, and then I'm going to leave you to finish it. This one is dealing with submarine. So it's going to be a deep flight sub. And again, think of a submarine. Submarine, the highest a submarine can be is sea level, so at 0 feet. If you're at 0 feet, you're on the surface. And then every foot down you go is going to go into the negatives. Rate of change, again, it's almost like a unit rate. It's how fast you change per unit of time. So rate of change, how how, in this case, since we're going to be diving down, it's going to be how many feet down you go per unit of time. To explore one of the last unknown regions of our planet, companies are starting to produce single-person submersible deep-sea submarines like Deep Flight 1. Suppose the submarine Deep Flight 1 is going to dive starting at sea level and descending. Descending means going down 480 feet every minute. So for every 1 minute of time, this sub is going down 480 feet. So it's doing down 480. So our slope is going to be negative 480 over 1. Change in y over change in x. Identify the independent and dependent quantities and their units of measure and define variables for these quantities. Then write an equation to represent Deep Flight 1's depth. So what do we have changing here? We have the independent time. The independent variable in this case is going to be time, because the more time you allow, the deeper this sub goes. So let's do the independent. And it said time was in minutes. So I'm going to use a T for time. That's going to be on the x-axis because I could have also used an x there. The dependent is depth. In what unit? Depth in feet. And we'll use a D for depth. So those are my two quantities and their units of measure. Oh, and then we need to write an equation for this. Well, depth equals, and how far down, how fast is this thing going down? It's going down at a rate of negative 480 feet per unit of time, per minute. So D, and it's starting at 0. So, I mean, it's when T is 0, when time is 0, this thing is at the surface. So this would be a plus 0. Plus 0 doesn't change anything. So I'm just going to write it like this. D equals 480T. This is going to be a proportion because it's going to form a straight line and it's going to pass through the origin. In our graph, use your equation to complete the table shown for the problem situation. Do not forget to define the quantities, units of measures, and the variables. So our independent quantity, that was time. The unit of measure was in minutes. And the variable that we used for time, we used T. Our dependent quantity, that was depth. The unit of measure for depth that we're using in this case is feet. They could have used phantoms, leagues, like 20,000 leagues under the sea, meters under, centimeters under, inches, miles. Again, these are just the two units that they chose for this problem type. And for the variable for depth we used was D. Well, you can see time is getting bigger. Like time is growing. Time is going to be a positive number, and it's going up plus 1 each time in this case. And they didn't trick us and suddenly change to a 16 or a 10. This is just going 0, 1, 2, 3, 4, 5, 6. So they maintained their pattern. They were being friendly. They didn't get cute with us. At 0 minutes in, how deep is the sub? Well, if we put in a 0 for, if T is 0, negative 480 times 0 is 0. If t is 1, negative 480 times 1 is negative 480. So this went down 480 for every minute. That makes sense because that really is our problem. The problem says the sub descends. It goes deeper, 480 feet every minute. So at 2 minutes, it's going to be double. 2 times negative 480 is negative 960. Because it's negative 480 more. And then negative 480 times 3, it's just going to follow that same pattern. That should be negative 1440. And this pattern is going to maintain for the next 3 problems. So 4, add 480 to that, negative 1920, negative 2400, negative 2880. And all this is, again, it's just following this negative 480 pattern. When t is 6, what does d equal? When d equals negative 480 times t, well, we said t is 6, so d equals negative 480 times 6. Negative 480 times 6 is negative 2880. We've just substituted in these values for t to find d. So if we were thinking of quadrants in terms of graphing, our time is on the x quadrant. It's getting bigger, 1 minute, 2 minute, 3 minute, and our depth is getting deeper. So this graph is going into quadrant 4. Remember, it goes quadrant 1, quadrant 2, quadrant 3, quadrant 4. That's our time as our x variable, and our depth is our y variable, or our independent. We can choose a time, and whatever time we put in, we plug in that number, and the depth depends on it. We find the depth. Consider the possible values for depth and time. What do you think all the possible values for time in terms of this situation? Write an inequality to express your answer. So the times, what's the smallest amount time can be? They start our table off at 0. So again, it makes sense to say 0 minutes in. Could you have a negative in this case? Would you really be talking about negative time? Probably not, unless you were talking about arriving before, like the sub had already started going down before you had arrived on the scene. But if you're there from the start, time is going to be greater than or equal to 0. What do you think all the possible values for depth in terms of this situation? Write an inequality to express your answer. Well, the biggest or the highest depth can be is 0, but then the submarine can't go into the air. All it can do is go down. So the highest it can be is 0, and then depth has to be 0 or less. Examine your table. What do you notice about each depth value in relation to the one before and the one after? Well, the one before it is 480. It's strange to say because, again, you're dealing with negatives. The one before it is 480 bigger because negative 480 is a bigger number than negative 960. So the one before it is 480 feet larger. The one after it is 480 smaller. And again, because negative 2880 is the smallest number on this chart. 0 is the biggest number on this chart with negatives. So what do we notice? The value before is 480 feet more, and the value after $480 feet less. The unit rate of change describes the amount that the dependent variable changes for each unit, for every 1 unit that the independent variable changes. So again, unit rate is per 1 unit. Miles per 1 gallon. You know, if a car can go 50 miles on 2 gallons, its unit rate is 25 miles per gallon. We want to know, in this case, feet per minute is going to be the unit rate per 1 minute. And they gave it to us. So in this problem, what's the unit rate of change? And again, we're dealing with our y variable is feet, our x variable is time. In minutes. So so feet per minute, and in this case it is negative 480 feet for every 1 minute. So our units are feet in minute, and the rate is negative 480 per 1 minute. A unit rate, again, has a 1. And with that, I'm going to let you use the formula now and see what you can do on the rest of page 158 and 159. Again, we're using the formula D equals negative 480 times T. So if they give you 2.5 minutes, substitute 2.5 in for T. 90 seconds, pay attention, because 90 seconds is not in minutes. You're going to have to convert this into minutes. 45 seconds, you're going to have to convert that into minutes to solve this, because this equation is based on time in minutes. So good luck with that, and I will go through the answers on a separate video. In this case, it's going to be tomorrow. Normally it will be in 2 days, but this week that we're working is a shorter week. So good luck.